All right, today we are going to do a full system overhaul. We're going to take your Raspberry Pi and turn it into an absolute AI powerhouse. So let's just jump right in.
Look, if you've ever tried to run a serious machine learning model on your Pi, you know the pain. You've hit that wall, right? It gets super hot, it crashes, and the performance, well, it's pretty much a joke. We're going to fix all of that, and we're going to do it right now.
So, what is actually going on under the hood here? I mean, why does this little device, which seems so capable on paper, just completely fall over the second you ask it to do some real AI work? Well, the answer is almost always the same thing. The culprit? It's a little thing called thermal throttling. Yeah. The second your prize processor gets too hot from a constant AI workload, the firmware just slams on the brakes. It's trying to save the chip from literally melting down. And that is the silent killer of your project's performance. And believe me, we are not talking about a small dip in performance. An uncooled Pi can lose up to 65% of its inference speed. Just think about that. That is more than half of your power just poof, vanishing into thin air all because of heat. You know, the hardware itself has come such a long way. If you go back to 2016, we were stuck with just CPU-bound AI. Then, around 2019, those USB accelerators came out and gave us a little taste of real power. But now we've got PCI. That's that super high-speed connection that lets us add some serious hardware. We're in a completely different league. But to unlock all that modern power, we have to solve that old, really stubborn problem first. Okay, so our first fix is, without a doubt, the most important one. Before we even think about touching software or plugging in accelerators, we have got to solve the heat problem. This part is completely non-negotiable if you want stable performance. Remember that little metal heatsink you used to just stick on top? Yeah, that's not going to cut it anymore. Not even close. With a powerful NPU, a neural processing unit, you're generating a level of heat that simple passive cooling just cannot handle. No way. The key here is to go active. Step 1, get a cooler that melts on the bottom. This is so important because it leaves that precious PCIe slot on top totally free for our AI accelerator. Step 2, make sure you're putting high-quality thermal pads directly on the NPU chip itself, not just the Pi's main CPU. And finally, step 3, a super simple command line tweak. You just tell the fan to spin up a lot earlier, which stops the heat from ever building up in the first place. Easy. And just look at the data. It totally proves it. We go from a really dangerous 85 degrees Celsius, which is deep in throttling territory, all the way down to a perfectly stable 62 degrees. And that's even under a heavy, continuous AI load. This right here, this is the foundation for everything else we're about to do. Honestly, the result is a night and day difference. I mean, you go from a system that's constantly stuttering and crashing to one that just works. It delivers peak performance, reliably, hour after hour. No more of those mysterious frame drops or jobs that just fail for no reason. All right, now that our system is cool and totally stable, it's time for fix number 2. We're going to unleash the specialized hardware that was literally built for AI. What we're talking about here is the NPU, the neural processing unit. The best way to think about it is like a math genius that only knows how to do one single thing, all those complex calculations that AI needs. By offloading the work to it, you free up your main CPU and you get this incredible performance boost. So get this. If you run a standard object detection model on just the CPU, you're lucky to get maybe 2 frames per second. It's sluggish. But with a modern NPU, you get 13 TOPS of power. Now, TOPS stands for tera operations per second, but you can just think of it as raw horsepower for AI. And trust me, 13 TOPS is more than enough for smooth, real-time video analysis. Getting this thing fired up is basically a 3-step process. First up, you make a quick edit to a system file to unlock the full speed of that PCIe slot. See, it's limited by default just to save power. Second, you install the specific drivers for whatever NPU you're using. And last, you just tell your AI software, hey, send all the heavy lifting over to the accelerator, not the CPU. And that's it. Okay, for our final fix, we are tackling the big one. We're talking about large language models. We've got this cool, fast system now, but these models, man, are they hungry for memory. And this is the central challenge, right? The math just doesn't seem to work. A pretty standard 8 billion parameter model needs something like 16 gigabytes of RAM to run. But a top-of-the-line Pi only has 8 gigs. So how on earth do we make that fit? The answer is this absolutely brilliant software trick called quantization. Now, in simple terms, what we're doing is making the model a little dumber, but in a really, really smart way. We reduce the precision of the numbers it's using for all its calculations, and by doing that, we can drastically shrink its size, all without losing much of its accuracy. It's pretty amazing. So here's the starting point. This is how much memory your standard, unoptimized large language model needs. We're talking double what the hardware can even hold. It's no wonder it just instantly crashes. But watch this. After we apply 4-bit quantization, that memory requirement just plummets all the way down to 4.5 gigabytes. It now fits comfortably inside the Pi's 8 gigs of RAM, with plenty of room left over for the OS and everything else. Problem solved. So let's put it all together, shall we? With our thermal fix, our hardware fix, and our software fix all in place, we have built a true edge AI powerhouse. But wait, there are just a few final little tweaks we can do to squeeze out every last drop of performance. So here is your final checklist. First, use the light version of the Raspberry Pi OS. That way, you're not wasting any resources on a graphical desktop you don't need. Second, boot from a fast NVMe drive. Don't use a slow microSD card. Third, use ZRAM to get some compressed memory swapping going. And finally, lock that CPU frequency to its maximum speed. That's going to give you super consistent and predictable inference times. And that's the real takeaway here. None of these fixes is a silver bullet by itself. They don't work in isolation. It's the combination, that synergy between powerful hardware, really aggressive cooling, and smart software that truly unlocks the potential of this incredible little board. And there you have it. The problem we started out with, that hot, crashing, underperforming device, is completely solved. Your Pi is now exactly what you hoped it could be: a stable, incredibly fast, and truly powerful platform for whatever AI project you dream up next. Think about it. You've conquered the thermal limits, you've unleashed the specialized hardware, and you've even tamed the largest of AI models. All that power is now in your hands. So the only real question left is, what amazing thing are you going to build with it?